Hi, I'm Krasm, and this is a Kenmore Elite Client Pack 4 HE3. I have a problem where I bought this last week, and it says F01 error whenever I plug it in and go to turn it on. That tells me it's the control board from all the research I've done. Should be a pretty quick, straightforward fix. We're going to have to take off these three 1/4 inch bolts, and then there's going to be a few 1/4 inch bolts inside next to the control board that we have to remove. So I have one of these magnetic 1/4 inch bolt removers. I got this whole set off of Amazon. They're nice because when you go to remove these sheet metal screws, they stick there instead of dropping like that. Very useful. I also have this screw holder, so I can put my screws there instead of losing them. Once you take off the top by removing these three screws, one of them's missing, you peel this back and your control board's right here. I'm actually going to move the camera so you have a better view, so give me a minute. Here we are at the control board. Obviously, before you start working on any of the electronics, you want to remove the power. I don't have a plug plugged up to there, so I'm good. So on this particular unit, I have a 1/4 inch screw here and another one right here. I'm also going to take these two off, that way I can move this a little bit and have a little bit easier access. There's a couple of wire holders, wire guides. They're right here. You can pinch them and you can move them out of the way. I'm actually going to get a pair of pliers to help me. It's just a little hard to pinch them for me. I don't have that kung fu grip. You don't have to take this step, but I'm taking it so it's easier for me to move the control board around and show you what is going on. There we go. There's actually 4 like this on the back panel that hold the wires. Like I said, you don't have to do that. It's actually unnecessary. It just helps with illustrating to you fine folks what's going on. So after doing that, you'll remove all of these wire connectors. You can take a picture, but for the most part, they're only going to go one way. So, because they are keyed, and these two, they're both your 120 volt combined together to make 240 volt hot. Actually, 120 combined together to make 208, or however that works. No, it is 240 because they're 180 degrees out of sync. So take those off. Take this connector off. This white connector, it pulls out. This blue connector pulls out. This, you pinch this to remove this blue connector. This yellow connector right here. Now the two problematic ones, these actually pull straight out this way. Let's see if you have that in the shot. If I have that in the shot, yep, we're still good. So I'm gonna come around this way so I can see it a little bit better. Yeah, these you push down and then you pull back out like that. Then you have this whole thing out. So there's a screw right here and a screw right here. I shouldn't actually have to take this off, but I'm going to anyways. Go this right here. And this just slides out, pops off, because the little ears go this way and that screw holds it from coming this way. And then you remove this sheet metal screw. They're all the same size, so you don't have to. Lucky me. They're all the same size, so you don't have to sort them differently. Now this, I was watching a video. Somebody said wiggle this. You actually want to flip it over and push this down. It slides right out. You don't have to wiggle it. It comes out without effort. So now, with the back sheet metal off, you pull up these, and you get back to the control board itself. What happens with these is this relay goes bad, the resistance shoots up really high, and it blows out these leads. I bought this off of eBay for about $8. You can also buy off of Amazon for roughly 10. To get this control board out, what you're going to do is you're going to move these tabs right here towards the front and pry up on the board a little bit. And then also get the other tabs on the other side. It'd be better if I used a screwdriver, but I didn't grab one. So when this comes out, you can see this relay. I already tried soldering it, it didn't work, so I got a new relay. This actually got blasted out. You'll see that in just a second once I get to my workbench and start working on this. Welcome back. So I have this set up on my table. This right here is the relay. It's a Omron G8P-1A4P. This one actually has ACD on the end. When you look up the spec sheet, that doesn't actually relate to anything, so it's probably a manufacturing code for this specific board all put together. You really just need to make certain that the relay you're getting is a 12-volt relay. That's good for 30 amps and 280 volts is what it says on here, if I remember right. 250 volts. So these are two spots of the main power leads. They come from this male spade connector on the other side and this male connector on this side. Both actually, or either one of these can blow out, looking at videos I've seen online. To fix this, what you want to do is tin your lead, or tin your soldering iron, remove the solder, and there's actually conformal coating on this, which is just a type of coating that protects this from humidity. I believe acetone will tear through it or help get rid of it. I actually just used a razor blade and cut through it. Once we get this wire off, you'll be able to see what the problem was for one of these. The other one actually didn't have a problem yet, but these are both the main leads. And this is actually a 12-volt switching part, which doesn't usually have a problem, but you will still need to unsolder these legs. Still pretty firmly connected. So I'm going to add some flux. I get this flux from Mouser? Yeah, Mouser. You can also get it off of Amazon. It just helps get the rest of the solder off. Because what it does is it wicks the solder out of the hole and away from the post. So hopefully I could just drop this relay out. The flux also helps clean corrosion from the area. Yeah, that should be almost good to go. Now I I just need to clean these areas. But what ends up happening is this relay it goes through a lot of work and gets the brunt of the surge, and the contacts inside the relay start getting worn and eventually stop working like they should. So they'll arc, and as they arc, it creates more and more heat. As it creates more and more heat, it creates more resistance. Eventually, it just blows the trace out. It could happen to either side because they're both getting the opposing voltage, so it adds up and turns into 240 instead of 120 because they are 180 degrees out of phase. Unless you're on a three-phase system, then they could be 120 degrees out of phase, I want to say. Yeah, 120 degrees out of phase. Alright. So you can see this relay right here. It's much shorter leg than that relay. So it got blasted. And you can see that side-to-side comparison. They're same shape, but this is probably half the size. So this kaput. I'm actually going to clean up this area a little bit more. Just got to move this wire. Solid core wire. So you shouldn't move it too much, but I have to keep the wire because this entire trace got blown out for the one of the hot sides. So I'm just gonna clean it up. Yep. And that's copper. I actually scraped back to copper so I could use some of the trace. This still has copper on it, and like I said, I just added wire to both sides. It's going to help reduce the resistance. It's not going to stop the relay from failing, because once the relay's resistance gets really high, it could blow out this whole trace, and no matter what you do, it's just not going to help. So make sure you clean up your area. I really should trim my solder wick, but I'm a little frugal, and I use it till I can't use it anymore. Alright. So now I'm going to stick the I'm actually going to clean this up with some rubbing alcohol, some acetone, and some Q-tips, and I'll get back with you. I'm back. I'm actually going to zoom in just a little bit so you can hopefully see what I'm working with. So we have this relay right here that we're actually going to pop up through the back. And you can see it's an Omron G8P-1A 4P 12 volt 30 amp 250 volt alternating current relay. So I'm going to have this down. Now the easiest way to get this relay to stick is have something under it. I'm going to use my solder wick because I'm not going to need to use it. Another thing to be careful of is when you're desoldering, like I was with my solder sucker right here, you want to get rid of any of the little strips of solder you might get. Is it in focus? Focus, focus. There we go. So we have the leads of the relay sticking up right here. What we're going to do is I'm going to use some solder. I'm going to tin my tip, which it just means, or wet the tip, just means get a little bit of solder on it. Then I'm going to press the hot tip against the edge of the post for the relay and wait for it to get hot. You actually want to get both the relay and the board hot and hold the solder against it until it melts. So once it starts melting, it'll flow and you'll get a nice, solid, firm, good solder joint. And because these are a repair, you want to make certain that the solder joints are very, very good. Because otherwise, you're going to be back where you started. So we're going to do this again. And you want to use rosin core solder, because if you don't use rosin core solder and you use acid core solder, it's just going to eat through the board and you're actually going to destroy all the hard work you did. So that one worked and got wet real fast. That one got. There we go. Now I'm going to move these back into place and solder them in place. Now hopefully you don't have to actually use extra wire. I do, because I blew the trace out on this specific one, and this is just giving you a little bit less resistance along that same pathway, since I'm actually bridging from here to the leg with solder. It's also going to come around this way. Let's move this back. And this is just to prevent the same thing from happening on that side. And you actually want to get the wire hot and the post hot. You don't want to drip the solder from the wire onto the post, because that also can create cold solder joints. Let's see, are you still in focus? Yep. So what I've done is I have connected via here. There's no bridge from here to here. Get that solder ball out of the way. This goes from one lead to the main power. This goes from the other lead right here to the other main power. What happens is the relay will close. These both combine, and then it energizes the rest of the board. Now, time to put this back in the dryer and see if it works. Welcome back. Now we're going to install it back into the dryer proper. First thing we're going to want to do, this goes down this way, so we want to put this back on the dryer right. There we go. This slides in this way. You just slide in there, push it down, and it clips into place. Not terribly complicated. This comes over the top middle right here and clips on. So those are back on. This is going to go back here, slide back. I'm going to attach the wire nuts, or not the wire nuts, the screws. I really have to stop setting my tools next to the tripod for the camera. So now what we want to do is we want to get these wire looms back up and back in place. So I'm going to come around this way and work my way from the front of the, or back of the dryer to the fronts. So blue goes right here. Right behind the blue comes this blue, light blue connector that goes on top. There's this wire loom push tab. There's another one right underneath this. This wire loom tab comes right here, and then it just goes straight towards the back. We have this connector back here, and there's a red one that is right here. Goes back here. Then this goes on top. This is a 5-pin connector right here that goes right there. The darker blue, black, and red go into these two connectors, and that should be all of them. Yep. Oh, one more wire loom connector. Take that out. Move that under. Connect the wire loom right there. So make certain everything is pressed in firmly. Flip this over. Add your 2 1/4 inch sheet metal screws to the top. Now you're going to go this far, you might as well take out the back. There's a bunch of screws on the back. You also have a, what is it? A 9/32 screw that holds on your external ground connector that you have to remove, and then 2 Phillips for your electrical junction box, which I'll show you in just a second. This is your electrical junction box right here. These are 2 Phillips screws you'll have to remove, and this is the 9/32 bolt, and then you'll also remove all of those screws along the outside, and then there's one right there and one right there. You do that, you'll be able to get the back off. Getting the back off is important for doing your replacing your heater core. It's also for replacing your belts, cleaning this whole thing out with compressed air, all which are good suggestions if you're dealing with a 10-year-old or older system like this is. So that's on. Those 2 screws are on. Now there's 2 little tabs, metal tabs right here, that this lid goes on top of and under. That's what helps catch the system and secure it. It's going to take me a little bit of finagling. There we go. I actually also took apart the system and got the screw that was missing. So I shouldn't be missing any more screws. So gotta put these back on. Yep, all my screws are accounted for. I'm gonna leave my back off for a second because I need to put on my 3-prong adapter for my house, and we're going to test this dry and make certain it works. See you in a second. Final test. See if it works. Alrighty, I like that. Two thumbs up. So it's sensing, revising time, medium, soft, that is neat. It has heat. It does. So, successful fix. So I bought this at a local hardware store. I don't know. I would say $70. And it was used. Obviously, the control board was out. So whoever bought a new dryer decided that they were going to give this to
the hardware store and they sold it to me as used. I fixed it, so what I'm going to end up doing is I'm probably going to go ahead and remove all the tape that's on the front of that, test it out for a little bit, make certain everything works like it should, and then hopefully sell it for a profit. So thank you for spending time with me today, watching me work on this and fix it, and I hope you have a good day, and thanks a lot.